Hello, today is April 28th, and we are going to do Unit 12, Lesson 4, and that's on page 418 through 420. And you'll need, if you can have 3 colored pencils with you, that would be great, and your calculator, and you have 2 pages of homework, pages 421 and 422. So let's get started. Um, Down at the very bottom of page 417, when you finished up your homework for lesson 3, you probably noticed that lesson 4, conditional probability, the title of this lesson was down at the bottom of 417, but it really starts up at the page, the top of the next page, 418. Now we're going to learn a new concept today. This new concept is called conditional probability. Conditional probability has its own symbol. We're going to learn that symbol, and it has its own formula. So you're going to learn a new formula. So let's get started with this. First of all, we're going to talk about a two-way table that we saw in another lesson last week. If you remember, we talked about a particular small high school with 52 seniors. Some were going to college, some weren't. And then you have the male and female broken down, and you have the numbers for each event. So this is just kind of a review of what we've done before. And male is going to be with an M, and F is going to be with an, or female is going to be with an F. C means going to college, N means not going to college. And what we're going to do is we're going to find probabilities here. Remember, probabilities are fractions or decimals, not numbers, but fractions or decimals. So what we're going to do is find the probability that a person was selected at random in this school that they were female. So you're going to go to the total female column. There are 22 females in this school of 52 people. So you could leave it like that as a fraction. That's a probability. Or you can take your calculator out and you can divide 22 by 52 and get approximately 0.423 to 3 decimal places. What's the probability that they're going to go to college? You're looking at the going to college row. There are 29 people going to college in this school. Out of the 52 total people that are going to the school, and if you want to write that as a decimal, it's just 29 divided by 52, and you would get about 0.558 if you did the division on your calculator. So now we have a new symbol. We have a new vocabulary word, and this whole lesson is going to be talking about this new vocabulary word, even though you've used this before. In probability, it has a special meaning. We're going to be talking about the word given. What is the probability that somebody's going to college given that they are female? Now here's the special symbol for given. It is just a little vertical line right here. That means given. And what this means is you are only looking at the female population. Given that somebody's a female, what is the probability that they are going to go to college? That's what this little shorthand symbol means. And so what we're going to do is we're going to draw a Venn diagram to help figure out what this would possibly be. So taking this two-way table set of numbers, we're going to transfer it into our Venn diagram. The first bubble is the whole female bubble. So the whole female bubble, we're going to say, how many females are there? There are 22 females. How many people are going to college? There are 29 people going to college. So remember, that's our little lollipop here talking about the whole thing. And then how many females are also going to college? Well, that would be the intersection between the row of going to college and the column of females. So that would be 13. So what this means is, given that somebody's female, so we're only looking at the circle with the female circle here. What is the probability that they're going to go to college? So what you can say is, well, there are 13 people that we're talking about, the probability that they're going to college, because that's what this 13 means, is these 13 are going to college, given that they are female. So this would be 13 girls going to college out of the 22 girls. So what this means is only looking at the female population, that's what this means right here on the other side of this little given bar, only looking at the female population. What's the probability of those people going to college? What's the probability that someone who is a female, of course, will go to college, or plans to go to college, I should say, question mark. So that's what that little thing means. So now down here, part D says, which is more likely, or which has a higher probability, that's another way of saying that a person picked at random will be going to college given that they are male. Going to college given that they are male. So this is the abbreviation for going to college given that they are male. So only looking at the male population, what's the probability that they're going to college? And then we're going to go to the second part afterwards. So if you're only looking at the female, or only looking at the male population, we are only looking at this column right here, this male column of 30 people. So only looking at males, what's the probability they plan to go to college? That's what this shorthand means. So only looking at the males, we're only looking at that column. What's the probability that they're going to go to college? Well, there are 16 of those males out of the 30 males. So 16 out of 30. And so 16 out of 30, if you wanted to do that division in your calculator, that would be about 0.53 repeating. So approximately 0.53 repeating, or 53.3%. Now, on the other hand, what is the probability that somebody is a male only looking at the people who are going to college? So this is a totally separate thing, even though they kind of look alike. Only looking at the people going to college or planning to go to college. So only considering those planning to go to college. That's this side of it. What's the probability that they're a male? That's what that really means. So now we're going to go up here, and we're only considering those who are going to college. So don't look at any other numbers. We're only looking at the going to college numbers, 16, 13, 29. Only considering those people going to college. What's the probability that they're male? Well, there are 16 males out of the total of 29 going to college. So 16 males out of the total of 29 going to college. So if you wanted to do that division, it's probably pretty close. 16 out of 29 is 0.551, approximately. So they're pretty close. So it says, which is more likely? That is the question. Make sure we answer the question. Which is more likely, that a person picked at random will be going to college given that they are male, or that the person will be male given that they're going to college? So that's the other side of this. This is the male given that they are going to college. That's this side right here. Which is more likely? Well, this one is a little bit more likely. This is a 55.1% chance, and this is a 53.1% chance. So this one right here, it is more likely. Pretty close. very, very close, but this is a little bit more likely to answer the question. Over on page 419, we have something called a generic Venn diagram. It just has a whole bunch of dots in it, and each dot just represents some outcome of a sample space. So we have two events. We have event A, we have event B. And what we're going to do is we're going to consider some probabilities. So let's look at only event A right here, and let's do our little lollipop. What they want us to do is just count up the number of dots in circle A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 dots in circle A. How many dots in circle B? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 dots in circle B, and 1, 2, 3, 4, there are 4 in the overlap. So those numbers are going to be important when we do our calculations. So what we're going to do is we're going to consider the probability of A occurring given that B has occurred. So this is the abbreviation for probability of A given that B has occurred. Here's that. So what we're going to do is we're going to only look at circle B. And what is the probability that event A has happened within circle B? Only look at event B, right? That is, the event B is this whole entire circle. What's the probability of A? So the probability, well, what happens here is there are 4 events that happened in A and B. So there are 4 times out of the whole entire circle of 12. So the probability of A given the B circle is 4 out of 12. So what we can do is, if you remember this part right here with our Venn diagram, this part is the and. This is the A and B part right here. And so what we can say is that this is equal to, I got the equals right, same. This is the number of elements in A and B both divided by the number of elements in only event B. That's how we can figure out the probability of A and B. But we also have the probability of A given B is equal to that, but we can also do write this out in terms of probabilities, because this is the same thing as the probability of A and B. Look, this is different. This is the number of elements, and this is the probability divided by the probability of B. So this probability of A given B is equal to the probability of A and B divided by the probability of B. And that's going to be talked about quite a bit more as we go along through these. So just keep this in mind, that this is the final equation for that. What we're going to do is look at a different situation when we have a two-way table. That in exercise 3, we're going to talk about situations of different hair color, black, blonde, or red, and given eye color, blue, brown, and green. Is there any kind of relationship between what the color of your hair is versus what the color of your eyes are? So there was a survey done, and they showed the population or the proportion of people that had all the different color hair, all the different color eyes. And what we're going to do is we're going to calculate some different probabilities. So right here it says, find the probability the person picked had brown eyes given they had blonde hair. That's the important part of this, is given that they had blonde hair. So only look at blonde. And the blonde is a column. So we're only looking at these numbers right here. Given that they had blonde hair, what's the probability that they had brown eyes? Well, where's the brown eyes? Here's the brown eyes right here. So here's the brown eyes in that blonde column divided by 0.35. So the probability of brown eyes, given that they had blonde hair, is the probability of brown eyes and blonde hair divided by the probability that they had blonde hair. The probability of brown eyes and blonde hair is 0.10. The probability that they have blonde hair is 0.35. And 10 over 35 is 0.286. Find the probability that a person had red hair. Here's the important part. Given that they had green eyes, you're only looking at the green-eyed row. Given that they had green eyes. So you're only looking at the numbers 0.05, 0.05, 0.15, 0.25. So these are the only numbers we're going to consider. And the formula is, what is the probability that they have red hair and green eyes? That's the numerator, and the probability that they had green eyes is in the denominator. So what's the probability that they have red hair and green eyes? Well, it's this intersection right here, which is 0.15, divided by what's the probability that they had green eyes? You're looking at this green-eyed row, that's 0.25. And if you divide 15 by 25, I think you get 0.6. Yep, that is equal to 0.6. So here is your big takeaway from this lesson. I don't know why they call it an exercise, but these are the formulas that you really, really, really need to know. So I'll put some little stars here. My red pen is going out of ink, but here's your formula. Probability of A given B, that is the same thing. This is the shorthand notation. This is the way you write it out the long way. It means the event A given event B. So you're only looking at the event B and what happens within the event B. What's the probability of A within that event B? And so this is called conditional probability. That's the whole title of this lesson, is conditional probability, and that's what the little notation is, this little vertical line here. In other words, B happened already. What's the chance of A happening as well? So now we're going to go on with our last exercise. We're talking about a hotel room. So we have a fancy hotel room, and this fancy hotel room has king-size beds in some of the room, and the probability that there's a king-size bed in the room is 62%. There's a probability that this downtown hotel has a view of the town square, 43%. And the probability that it has king-size bed, and remember, we only need 3 different probabilities to fill out a hypothetical 1,000 table, and that's what we're going to do in this problem, is 0.38. So K means it's got a king-size bed. V means it has a view of the town square. And what does it mean, probability of K given V? Well, what this means is you're only looking at the rooms with a view. So only looking at the rooms with a view, what's the probability of those rooms having a king-size bed? So only looking at rooms with a view, that's the given V part. What's the probability that there's a king-size bed in it? That's what that means. So we're going to have our hypothetical 1,000 table like we learned yesterday. So our hypothetical 1,000 table, you're going to start out with a total of 1,000. We're going to say, let's imagine that this hotel has 1,000 rooms in it. That's what this hypothetical 1,000 table really means. And that helps us fill out probabilities here. So the probability that the room has a king-size bed, this is the king-size bed column, K, the probability is 0.62. So we have 620 because 0.62 times 1,000 is 620. The probability that it has a room with a view of the town square is 0.43. 0.43 times 1,000 is 430. And the probability that it has both a king-size bed and a room with a view is 0.38. So 0.38 times 1,000 is 380. So now I think that's all we need in order to fill out the remaining 1, 2, 3, 4, 5 columns. Let's see. 1,000 minus 620 is 380. 430 minus 380 is 50. 380 minus 50 is 330. 620, oh, I'm going to have a calculator for that. 620 minus 380 is 240. And 240 plus 330, that looks like it's 570. And these two add up to that. So our whole hypothetical table is filled out. So now what we're going to do is do some conditional probability calculations here. Remember, this is what you have to memorize, probability of A given B. Make sure you know this, and it doesn't matter what the letters are. We're going to use the letters K and V. So the probability of K given V is equal to the probability of K and V divided by the probability of V. Remember, it's that second one. Or we can say the number of rooms that have a king-size bed and a view divided by the number of rooms with a view, because that's what we get off from this table is the number. So the number of rooms with a king-size bed and a view is 380 divided by how many rooms have a view? 430. So you can divide 380 by 430 and you can get 0.884. Approximately 0.884. This is the exact probability. This is an approximation because it would be lots and lots of decimal places. So how does the probability that you calculated the formula compare to the probability you calculated using the hypothetical 1,000 table? They are the same. And that's it. And if you have any questions on any of your homework on the next couple of pages, remember your homework is on pages 421 and 422, the next two pages. If you have any questions, please send me a chat message. I hope everybody is staying well.